Today's lesson is on biconditionals and definitions, and we're going to start by talking about what a biconditional statement is. It's a single true statement that combines a true conditional statement, and its true converse. So if you remember from last lesson, a conditional statement and its converse are not logically equivalent all the time. Sometimes they are. And in the case when they are, then we can write a biconditional statement. So I copied this box right from the textbook, as I often do. So it says a biconditional combines if P then Q and if Q then P as P if and only if Q. So the way to read that is P if and only if Q. That's the little double-ended arrow. Sometimes you might also see it like this. That means if and only if, and sometimes if we're writing this instead of using symbology, we would write if and only if as IFF. Okay, so when we talk about writing definitions, we know that a definition is good if we can write it as a biconditional. So I said, for instance, let's write the definition of pencil and then see if we've written a good definition by rewriting it as a biconditional. So let's see, what do you think a pencil is? A pencil, let's try this, is something, maybe don't write this just yet, guys, because I might change my mind. A pencil is something we write with. You think that's a good definition? Well, here's how we're going to find out. We're going to write it as a biconditional. So I'm going to say an instrument is a pencil if and only if you write with it. Okay, so if it's a true biconditional, that means I can say it either way. So I could also say an instrument, let me see how I would write that. And, well, I can't even really think how to write it in the reverse way, but this is telling me that a pencil is the only thing I write with, essentially. So that is not a good definition, is it? That's not a good definition, so we have to improve our definition so that we could write it as a biconditional. How about if I do this? A pencil is a writing instrument with lead. I think that might make it better, but let's see if we can write it as a biconditional. A writing instrument is a pencil if and only if it has lead. If and only if the instrument has lead. And yes, that is a biconditional, a true statement, so that means we do have a pretty good definition here. Let me see if I can think of how to say this backwards. A writing instrument has lead if and only if it is a pencil. So yeah, see, for the biconditional, you have to be able to say it either way and have it still be true. Okay, so here's some more examples. An angle is a straight angle if and only if its measure is 180. So let's go the other way. Let's rewrite that as a conditional statement. How about this? If an angle is a straight angle, then its measure is 180 degrees. That's definitely true, right? But remember, we have to be able to say it the other way. The converse has to be true in order for this to be a biconditional. So the converse would say, if an angle's measure is 180 degrees, then it is a straight angle. So that is a good definition, and that is a biconditional. Okay. I kind of got ahead of myself here. The converse says, I just said this, if an angle if an angle's measure is 180 degrees, then it is a straight angle. So since the conditional and the converse are both true, I know that I can write this as a biconditional. Okay, how about the next one? A square is a figure with 4 right angles. Is this a biconditional statement? In other words, is it true? And why or why not? Well, let's go to the next page and answer these questions before we do the why or why not. So rewrite it as a conditional statement. I got to remember what it was first. A square is a figure with 4 right angles. Okay, write it as a conditional. So I'm going to say if a figure is a square, if a figure is a square, then it has 4 right angles. Okay, write the converse, because remember, we need both the conditional and the converse to be true. Is the conditional true? If a figure is a square, then it has 4 right angles. Yes, that's true. So far so good. Write the converse, okay, if a, so remember this is if Q then P, that's what the converse is. If a figure has 4 right angles, there's my Q, then it is a square. Is the conditional statement true? Yes, we said it is. Yes. How about the converse here, though? If a figure has 4 right angles, then it is a square. Not necessarily, right? It could be what? It could be a rectangle. So remember, we said if we're going to say a statement is true, it cannot have even one counterexample. This one has a counterexample, which is a rectangle, so the converse is not true. Therefore, we cannot write a biconditional. So if you want to go back to the previous page and say, no, this is not a good definition, it's not a biconditional, that's because I have a counterexample to the converse. Okay, so what I have left for you here are just some practice problems. So as always, I want you to pause here and I want you to work on these and then come back. All right, here we go. So the first one says if the square root of x is 1, then x equals 1. The converse of that would say if x equals 1, then the square root of x equals 1. Both the conditional and converse are true, so I can write it as a biconditional. Number 2 says if 2 angles are vertical angles, then they are congruent. Well, that's true, but the converse says if 2 angles are congruent, then they are vertical angles. And we know there's a counterexample to that right here. I can have all kinds of angles that are congruent, but they're not vertical angles. So we cannot write that as a biconditional. And number 3 says if 2 angles are supplementary, then the sum of their measures is 180 degrees. And that's true. The converse would say if the sum of the measures of 2 angles is 180, then they are supplementary. We know both of those are true, so we can write it as a biconditional. That's actually the definition of supplementary angles. And finally, we have a biconditional, and it says write the 2 statements that this biconditional is made from. So I wrote the conditional here. I wrote the converse here. Both the conditional and converse are true, so we do have a good biconditional. All right, so this would be a good day to write a summary. You learned a lot of things in this short little lesson. And also I put you a little note here. If you need some more practice, see page 101 in your textbook. And of course, you also have plenty of worksheets in your classwork packet you can start on. All right, we'll see you next time.